Hi, my dear students. How are you? Hope you're doing fine. This is Miss Haneen. We're gonna have today a new lesson and a new chapter. Our chapter, the new one, is chapter 11, which is about ratio, proportion, and percent. The first lesson of our unit is about understanding ratios. It's on pages 646 to 647 in your student book. The main objective of our lesson is to read and write ratios for various kinds of comparisons. Our plan is to learn how to read and write ratios, and we're going to solve some questions from the book, page 647. Our instructions, as usual, you need to download all the attached resources, open your book, open your new notebook, a new page, write the date and the day and the lesson title. Follow the instructions in each slide. You can repeat watching as many as you want. Solve the questions from your student book in the notebook as the slides mention. Are you ready to our lesson? Let's start. How can you use math to compare quantities? We know that in general, we can compare. If we have 2 glasses of water, we can compare which glass has much amount of water by just looking. But you know that we can also use math to compare things. So if you look at this shape here, and we have parts that are blue and parts that are red. We're gonna learn today how does that ratio written here, what does that mean, and how do we read it? We're gonna learn that together. Ratios are used to compare 2 or more quantities. So we can compare juice, we can compare whatever the quantity that you can use, we can use ratios to compare it. A ratio is a comparison of like or unlike quantities. What do we mean by like or unlike? Like quantities are quantities that have the same units. We are comparing same units, like kilograms to kilograms, centimeters to centimeters, millimeters to millimeters, grams to grams. But when we have unlike quantities, we might compare something with kilograms with another thing is in grams. Or we can compare a length of centimeter to a length of meters. We can compare millimeters lengths to centimeters lengths. The ratio can compare part to part. Now look, how are we going to compare and write ratios? Here we have random shapes. Some of them are pink, some of them are blue. If you count all the shapes here, you're gonna find that you have 15 shapes in total. Blue and pink all together here are 15. If we need to compare the pink parts to blue parts, how many pink parts here? You just count them. There's 1, 2, 3, 4, 5. So 5 pink, 2. If you count the blue, you will find 10. So 5, 2, 10. Comparing something to another thing. And we can also compare part to whole. So for example, if we need to compare the pink parts to the whole parts, whole number of parts, how many pink? We look, compare pink, started with pink, so count the pink. There is 1, 2, 3, 4, 5 pinks, 2 whole. Whole number of shapes are 15. So 5 to 15. So see, I started reading pink, So the first number we write is the number of pink. If we need to compare, look, blue parts to the whole. How many blue parts do we have here? 10 blue parts to 15 whole parts. We can, by the way, do the opposite. We can compare whole to part. Like, for example, if they tell you compare the whole number of parts to the pink, you might say that, teacher, it's the same, pink to whole and whole to pink. No, in ratios, it's very important to follow the ordering of the words in the question. Here, we started saying compare the whole. So how many whole shapes do we have? 10. To how many pink parts? 5. Exactly as if you use the blue. There are 15 whole to 10 blue. Now there are 3 ways to write a ratio. So way number 1, we can use the word to, T-O, to, because comparing something to another thing. So here, write the ratio of the blue amount to the red amount. Look at the blue. How many blue amounts do we have? Just count the lines. There is 1, 2, 3, 4, 5, 6, 7. So the blue, 2. Red, we have 7 blue, 2, 1, 2, 3, red, 7 to 3. So this one, 7 to 3, as number 7, TO to 3, is a one way to write the ratio. Again, this is a very important note. Ordering is important when you write the ratio. It says in the question, write the ratio of blue first to red. So you start with blue, which is 7, to red, which is 3. You can't write the number of 3 before the 7, which is related to blue, because the question mentioned blue first, so write the number of blue first. Another way to write the ratio is the columns. The columns, the 2 dots over each others instead of the word to. But the columns, we read it to. Okay, so we need to write now the ratio of red to blue. Red to blue. So see, I didn't write TO here. I just put the columns, but we read the columns as 2. Red to blue. So how many red parts do we have? 3. To the blue parts, 7. 3 to 7. So we read it 3 to 7, but we can use columns. And we can use another way number 3, which is using the fraction bar, the bar of the fraction. So here, write the ratio of blue to red. Look, blue to red. It doesn't mean a fraction here, blue divided by red. No, it has the fractional form. It looks like a fraction here, but this is actually ratio. So blue, how many blue parts? 7 over 3, but this is not a fraction. Remember, we are doing ratios here. So this is 7 to 3. 7 blue to 3 red. So keep it as is. Don't ever change. If you look at this, you might say it's an improper fraction, so I want to write it as a mixed number. No, be careful. Keep it as is. We are just using the shape of the fraction to represent the ratio, but we don't deal with it as a fraction and do the simplest form and changing to mixed numbers and so on. So just keep it as is. Let's do more examples. So as you see here, we have red dots and green dots. Write the ratio of red counters to green. What did I start saying? Red or green? Red. So you first write the number of red. We need the three ways of writing this. So first count the red counters. We have 1, 2, 3, 4, 5 counters and 3 greens. We can write it either by using the word 2, 5, 2, 3, or we can use the columns 5, 2, 3, and we can use the bar of the fractions 5, 2, 3. So see, in the three ways we read it 2, and in all the ways we started with the red number 5 because they say in the question red to green. Now here we need to write the ratio of green to blue counters in the three ways. Can you think of it? Excellent. The green are 4, the blue are 5. So green to blue, you can either write it with 4 to 5, or 4 to 5 with columns, or 4 to 5 with the bar of the fraction. Now look here. Write down ratios to compare the following quantities. 5 yellow blocks to 3 red blocks. 5 yellow to 3 red. So yellow to red is 5 to 3. Why did we use columns? Why didn't we use any other thing? It doesn't matter which way you use. You can use it with columns, you can use it with the bar of fractions, and you can use with the TO itself. Which one you want to use, it doesn't matter. If the question didn't mention any of the three ways is totally correct. Question 2, 10 boys to 14 girls. So we're comparing boys to girls. So boys are 10 to girls. I used TO here. Number 3, 50 ml of water to 5 ml of orange. Water to orange. What if I want to write orange to water? Can I choose 5 orange to 50 water? No, of course. The question wrote this with water first, so you have to stick to that. Water to orange. If you use the fraction bar, it's 50 to 5. But what if I divide? 50 over 5 is 10. Can I write it equals 10? Of course you can't, because we are not dividing here. We are comparing. So keep it as is. Here, write each ratio in 3 other ways. So we need the 3 forms of writing the ratio. In part 1, the number of triangles to the number of circles. So how many triangles are there? Let's count them. There is 1, 2, 3, 4, 5, 6, 7, 8 triangles. To the number of circles, there are 1, 2, 3, 4, 5, 6, 7. Be careful. The green and the orange are not circles. These are ovals, so we don't count them. The circles are only the 2 pink circles and the 5 gray circles. So we have 7 circles. So 8 to 7, or we can write it with columns, or we can write it with the fractional part. Number 2, we need the number of circles to the whole number of shapes. We counted the circles already. We got 7 circles. All the shapes, you count all the things you can see all together. We have 28 shapes. So it's 7 to 28 in the 3 forms of it. Columns and fractions and the word TO. Let's practice now from the course book, your student book, page 647. I'm gonna give you 4 minutes to do questions 1, 2, 3, 4. You need to write each ratio in the 3 forms of writing it. Once you're done, you can continue watching. So pause it now, solve the questions in the notebook, then continue watching to check your answers. Let's see the answers now. Yellow shapes to blue shapes, 10 to 3, or with columns or bars. Blue to all the shapes. There are 3 blue to 20 shapes. All shapes, which is 20, to the green ones. The green ones are 7. Blue or green, look at this, blue or green. So to all the shapes. So blue or green, if you count the blue and the green shapes all together, we have 1, 2, 3, 4, 5, 6, 7 squares, 7 green squares, and 3 blue. 7 and 3 is 10. Okay, so again, where did we get the 10 from? It says blue or green. How many blue do we have? 1, 2, 3, 4, 5, 6, 7 blue. Or, it says or means the green ones are 3. So 7 and 3 is 10 altogether. It's 10 to all the number of shapes, 20. Okay, these are the 3 ways. You have another 6 minutes to do these questions 5, 6, 7, 8, 9, 10. So take your time with 6 minutes, pause the video. Once you're done, you can continue watching to see the answers. Let's check the answers. Now, number 5, is the ratio 42 to 6 the same as the ratio 6 to 42? Of course not, because we say that the ordering is very important. So 42 to 6 and 6 to 42, they have different ordering, so they're not the same. Now the number, question 6, this is data file at the right. It's about the birth order here and the number of presidents. Use the data file here to write the ratio of question 6, number who were second born to third born. Second born, 12. Third born, 5. So 12 to 5. It doesn't matter which way you use, you can just write one of them if the question didn't mention the 3 ways. Any of them is correct. Number who were sixth born to the total. Sixth born is 2. To the total, as you see, 42. Any of the 3 ways is correct. And this is number 8. Fifth born to sixth. Fifth to sixth. 2 to 2. Number 2, only children to total. Only children, 3 to total, 42. Now look at question 10. It says, no president was eighth born. Does the ratio 42 to 0 make sense for this data? What do you think here? Yes, it does. What? Because nothing for eighth, it means 0. So yes, this is the ratio of the total number of presidents to the number they were eighth born. 42 to 0, it means the total number to 0. Thank you for watching our lesson. Hope you enjoyed the lesson. It was quite easy and interesting. It's like a piece of cake. So I think you can do the homework easily now. Your homework is due Thursday, 23rd of April. We will not accept any homework after 2:30 p.m. Please be committed to do your homework because your marks for the third assessment has a big part through the homework and how much you are committed in doing it. See you next time. Bye bye.